everyone. My name is Tracy Homer. I'm doing a talk about open source mapping and art. We're all here for open source mapping. I work at the Software Freedom Conservancy. It's not a geospatial organization at all. It's an advocacy organization for open source projects. On my free time, when I'm not working, I help administrate our local makerspace, which is in Knoxville, Tennessee. It's like a general community makerspace. We've got metalwork, art, metalwork, woodworking, laser cutting, 3D printing, all those other things. And I recently graduated from the University of Tennessee with a degree in GIST. And this all has coalesced into art maps. So nearing the end of my schooling, one of my professors came to me, Michael Campanovo, some of you know him, and he said, would you like to do an independent course where you make maps with open source at the makerspace? I'm like, this is the best thing I've ever heard, and get credit for it. So I did that. It was a full 3-credit course. I documented it all on my website, and I'm going to tell you a little bit about the different types of maps I made, some of the tips and tricks I learned, and yeah. The first map I did was a cross-stitch map of Tennessee. So this is like, I feel like it would fall under tiled or pixel art. So it maybe not necessarily has to be cross-stitch. You could use mosaic tiles. You can knit if you're doing like a color pattern. You can do Lego. Sometimes people like light up LEDs in different patterns. But it's basically like pixels in different colors. And it's pretty easy to come up with this because you really just need a picture. You don't actually have to do any geospatial, but of course, if you want to make something super custom, you can. For this project, I used a program. The types of maps you could use for something like this is probably going to be something with bold colors and high contrast, like this quick map that I pulled off the internet of the United States. Heat maps and elevation maps might work, but then you're going to run the risk of having a super complicated pattern, because if you want to gradiate the colors, you're going to have a lot of different colors to use, and your pattern's going to be very complicated. The program I use for this is called C-Stitch. It hasn't been maintained in quite a while, but it worked perfectly with 0 errors, which was amazing. And it basically takes any photograph you dump into it and dumps out a cross-stitch pattern in PDF form. It will color match and like tell you which colors embroidery thread to buy. If you're not doing embroidery thread, you can use Lego or mosaic tiles, but basically it will give you a nice printable pattern that works great. So I put my US map in there, and it tried to make it into a pattern. And you can see some of the choices you have to make when you're picking your picture. So if the colors are too close to each other, it's going to try and make it the same color. Or if you can choose how many colors you want to use in your design, and if you choose too many colors, it will try and like make it fade in between the two, because it wants to make it look like a photograph. It doesn't necessarily want the strong lines. So if I were actually going to do this map, I might go back and you can see Massachusetts and Vermont have sort of like melded together. So I might change the colors on some of those. You can also edit this pixel by pixel. So you can see that Nebraska is kind of funny looking. It's got like a sticky up bit. I changed that before printing out the pattern. So you can say how big your pixels are, how many pixels you want, how many colors you want to use. You can customize all of that stuff, and then it will print out this great PDF for you, tell you how many pixels are in each color so you can know what you need to buy, what the color code is if you're buying DMC floss, and then has the little symbols that will mark out on your printout. So here's a couple of images I just threw in there for fun. This is a Portland map of their light rail system. You can see the words didn't really come out well. That's fine. But the colors of the transit lines came out well, so you get the general idea of what you're looking at. I felt like this one came out really nicely. The forest was gradiated. You can tell the difference between the other wooded land and the forest. It was big enough that you could see the difference and like make out the color or the country borders, the continent borders. But I feel like this would take a really long time. Oh, one other thing I should comment is that if you do have something with a white background, it will tell you to stitch all the white in, which maybe you don't want to do, so you can ignore that part. You want to keep one color reserved for background white. This is a heat map. It didn't really work out very well. You can see like these areas are supposed to be sort of lighter and you can tell the difference between them. But when you translate that into embroidery floss or pixels, it doesn't translate well unless you would have a ton of colors to get that very gradiated, which would frankly be a lot of work. The second kind of map I made was a CNC laser cut map. This is my hometown of Sheboygan. Basically, I just took the data from their open data portal and I printed out, or I extracted the streets, put a buffer around them. I extracted the county line, and which included the river, and put it into Inkscape, which is my favorite vector editing program. Inkscape puts out SVGs. If you have a CNC machine or a laser cutter, a lot of them will take SVGs. If you have a laser cutter or have access to a laser cutter that doesn't take SVGs, usually Inkscape will be able to export into whatever file format you need. It's very versatile. I love it. There are some, to get an SVG out, you want to go into QGIS and go to the print view, and you can export from the print view as an SVG. It will make everything in your print layers its own layer in Inkscape. There's a couple of little tweaks, bugs, problems that you have to work around. One is you can see in my print view that it was nicely cropped and looked great, but it was not nicely cropped when I put it into Inkscape. For some reason, it just like expands out. You could shrink it, but the problem with that is that I also exported the scale bar, and if I were to change the size of anything, the scale bar would also be inaccurate. So I basically had to just like clip it using the Inkscape tools. The other problem you would run into is that you can see on the left side is like all the objects. They're nicely divided up by all the different things I had on my map, but there's also a lot of empty objects for some reason. I still haven't figured out what they are or why they're there, but when I export something into Inkscape, basically the first thing I do is just delete all the empty stuff, because it's really hard to find what you're looking for if there's like, how many are there? 10, 12, just nothings. It gets really complicated when you have more objects. Another laser cut map that I did is the hydrology of Tennessee, which is all the rivers and lakes in the state in Tennessee. Well, not all the rivers and lakes in the state of Tennessee, because when I downloaded the data, there was 2.6 million rivers and 200,000 lakes. So another thing you're going to want to do if you're making artistic maps is just delete everything that's like less than 5 miles or something. Like, you're never going to see that if you're printing it or if you're cutting it out on a laser cutter. It's just going to be completely fade. So delete all the teeny tiny little things, and then you have a much more reasonable size of 1,600 rivers and 234 lakes. So this I also exported into Inkscape, and then after I cleaned out all the empty objects, I got this out, almost ready to send to the laser cutter, except since it is such detailed information, the number of nodes in each of these lines is so huge. It makes the file size like really large, and it makes everything very sluggish. So skimming straight out of QGIS, that one red line had 184 nodes in it, which is a lot, especially if you have 1,600 rivers. QGIS has a vector geometry like simplify tool, which got that down to 30 nodes. That's much more reasonable. Inkscape also has a simplify tool, which got that particular river down to 31 nodes. The problem is that in Inkscape, if you select all of the rivers and try and simplify them all at the same time, it goes a little too far, in my opinion. I didn't like the look of this. It was too simplistic. So if you're doing only one object, maybe it would be better to do it in Inkscape, or maybe it'd be better to do in QGIS. You kind of have to just play around and see what you're looking at. Another problem that there was 1,600 rivers. They're each their own object. I mean, to our eyes, you can see that they look like they're connected, but of course, in maps, that doesn't always mean that they're the same object, right? So QGIS has a dissolve function, which put them all into the same line in QGIS, but when I exported it into Inkscape, it still was 1,500 objects, so it didn't really help. It didn't actually put them together. There is an Inkscape extension that I found called Optimize Paths, and that got it down into 631 objects, which is a lot nicer, a lot faster. The extension took 20 minutes to run when I didn't touch my computer, and every time I tried to I'm going to surf the internet while I'm waiting, it just crashed. So, however, when I originally tried to cut this out on the laser cutter, it took 3 hours. And after I ran this tool, it was down to 1 hour. So the 20 minutes of walking away and not touching my computer was well worth it. It saved a lot of time. I don't know if you have used a laser cutter or a CNC machine, but sometimes with the one that I have, it will not pay attention and do all the paths here and then all the paths here and then all the paths here. It does a path here and then goes all the way to the other side and does a path here and then goes here. It doesn't do it in any particular order. So making those all green things into one path actually did save a lot of travel time for the laser to go back and not go back and forth. The third type of map I want to talk about is a 3D printed DEM map. And there's a QGIS plugin that will just take your DEM and put it into an STL. There's really nothing else you have to do about it. You can just take any DEM that you download off the internet. I looked at a few different raster sizes, like 90 meter versus 10 meter. It didn't make a whole lot of difference because when you smush it down into 3D printing, it's quite small and you can't really tell the difference between 2 meter or 5 meter or whatever, except with file size. For this particular project, it was the entire Appalachian Trail, so that's the whole east coast of the United States. So I picked 90 meter because the file size was getting completely obnoxious and I didn't want to spend a whole week downloading DEMs and then trying to put them together. So the QGIS plugin will take your extent. It will ask you some specific 3D printer questions like how big do you want the spacing? It will ask you how big physically you want your model to be depending on how big your bed size is. And then the scale, because it will, or not the scale, the vertical exaggeration, because it will make it more exaggerated if you have interesting features. So this is a model I did of Mount Hood in Oregon. I just basically downloaded it and did nothing to it and just dumped it into the program and see what happened. And then here's an example of the different exaggerations. So 1x, 1.5x, and 2x. I think for something like this, 1x ended up working out okay. 2x gets kind of pointy in my opinion. And what I found between doing this one and doing the Appalachian Trail is the larger the area that you're mapping, the more exaggeration you're going to want. But you also have to be careful because if you do a very large area, you might have a part that's very flat and boring, and then a part that's very mountainous and interesting. And if you exaggerate the mountainous part so it looks good, the flat part might just be nothing. And if you want the flat part to look interesting, the exaggerated part might be the mountain, huge, ridiculous looking mountains. So Tennessee's not great for if you want to 3D print the entire state because it's very different on both sides of it. Another issue, or another thing that the plugin can do, is it can divide your model up into reasonable size tiles. I could not fit the entire Appalachian Trail on one print bed, so I thought, I'm going to have to slice this up. And I wanted to slice it so it would be like this, like very nicely across the trail. And the plugin does not let you do that. The plugin wants to slice it on the latitude and longitude 90 degrees. So that is why there's this gigantic bounding box around it that I had to make all 0 height. I tried to get rid of it and still do it, and then it wanted to make the model infinite height, or what I originally thought, and then I later found out it was actually physically 46 kilometers high. So did not fit on the printer. So I had to make the entire bounding box 0 height, and then when it translated over into the STL, it gave me the empty. It didn't print that part, obviously. So here's a picture of the tiles after they printed out, and then I painted them, and you can see that it's not nicely sliced like I had hoped, but it ended up actually being sort of cool looking. It made it more of a difficult puzzle. I have it here with me if anyone wants to see it during one of the breaks and try and put it together. It's fun. Other ideas, currently I'm working on an embroidered globe. You might have seen me stitching it during the talks. Someone told me about a quilted map, which I thought was really cool. 3D printed cityscape where you take buildings. I'm not sure if that would work in the DEM or not. I would have to check that out, but I suppose if it doesn't actually care if it's a DEM, if it's just a raster image with height information in it. Contour maps, I've seen people do those with the laser cutter where you like build up different layers. I have not tackled that one yet because it seems really difficult and complicated. Every place that I look up that I think would be cool has like 1,000 pieces, and I don't know if I can have the patience to do that. Maybe someday. Also like an LED transit map that will connect to the web and see, like when is the train coming, when is it going to be there, and then like move the LED down the line. I think those would be really cool, but I have not made any of these yet. And that's my presentation. Like I said, all of the documentation's on my website if you want to see how I did it. If you want the patterns and like just skip all the how-to and get straight to the file, I'll gladly send them to you. And I'd like to open it up for questions. Nobody? Yeah. The question is, will my makerspace have all this cool stuff? And the answer is probably yes. They end up being very similar with laser cutters and 3D printers because those are pretty easily accessible. A lot of them have wood shops and metal shops with basic tools. The one that I have is a community minded, so like it's fairly reasonable fees, and then you just join and pay a fee and you can go anytime you want. And I can almost guarantee that San Francisco has one. It's big enough that if Knoxville has one, you all have got to have one. Yeah. The question is, have I thought about using bathymetry? That my embroidered map is using that, which I have with me. But I haven't thought. I originally thought about printing like a 3D printed globe that had no water on it, so like the entire ocean, but I didn't get around to it. I think it would be cool though. Yeah. Yes. I have it documented. I don't have it published yet, but I will tell you about it. So the globe process, I use two QGIS plugins. I wanted to make the pattern myself using ocean depth, and which is difficult because the earth is round and my computer's flat. So that was like, and also the raster that I found that had the ocean depth information was gigantic, and it just kept causing me huge problems. So the two plugins that I used were Beelines and Globe Viewer. I think it's called Globe Viewer, but I can make sure of that later. The Beelines will make, oh gosh, what's the line where it doesn't go straight across, but it follows my mind is blanking. It follows the Great Circle line from point A to point B, which is important if you're doing something round. And then Globe Viewer will take your projection, whatever center point you have, and put it into a globe. So what I did was I took the raster image that I wanted to use. I put the B lines on it, the Great Circle lines, to make triangles that all fit together and didn't like try and slice because round earth. And then I put each center of it into the Globe Viewer and exported the image of each tile. It's an icosahedron essentially. So it has 20 tiles, map tiles, quilt tiles that I'm going to sew together. But it was really a long process trying to figure that out. So I will gladly share it with anyone so they don't have to go through that pain. Oh, and additionally, the projection that I used, the Mercator projection, was great for the equator. Then I had to change to 2 polar projections to get the poles. And then, unfortunately, right around negative 180, it didn't do what I wanted it to do. So I had to change it to like a China-Australia projection just to get that tiny strip, the last strip of the globe. So I'm glad to be doing the stitching bit now, because I think the other part took just as long. Anyone else? I think we're yeah. Oh gosh, that's a great question. If I had a dream map, what would I work on? And no budget constraints? Oh man, I have no idea. That's like too big of a question. I would love to make a map or anything really, that involved every zone of our makerspace, which there's 10 different work zones. So metal, wood, thread, electronics. That would be super fun, but I have no idea. I'm open to ideas if anyone has them. I think that's time. So thank you all for coming.